Relative frequency distribution. A variation of the basic frequency distribution is a relative frequency distribution. In a relative frequency distribution, the frequency of a class is replaced with a relative frequency, or a proportion, or a percentage frequency as a percent. Note that when percentage frequencies are used, the relative frequency distribution is sometimes called a percentage frequency distribution. In this particular course and the book, we use the term relative frequency distribution, whether we use a relative frequency or a percentage frequency. Now, relative frequencies and percentage frequencies are calculated as follows. The relative frequency for a class is the frequency for a class divided by the sum of all the frequencies. Now, the percentage for a class is equal to the frequency for a class divided by the sum of all frequencies and then multiplying it by 100%. So what we're going to do is we're going to use the daily commute times in Los Angeles in the table below to find the relative frequency distribution. Okay. Now, before we do that, what we need to do is we need to find the total of the frequencies. So here was our classes. Here is the frequency. So we need to add up 6 plus 18 plus 14 plus 5 plus 5 plus 1 plus 1, and that gives us a total frequency of 50. So that is the sum of all frequencies. Now that we have the sum of all frequencies, now we can find the relative frequency. So let's take a look here. Here's our title for relative frequency. And so what do? The first one, we take the frequency 60, we divide it by by 50, the total. 60 divided by 50 gives us a decimal of 0.12. Multiply it by 100% gives us 12%. So it can either be, a relative frequency could either be 0.12 or as a percentage 12%. Next, we have the frequency of 18. 18 divided by 50 gives us a decimal of 0.36, or as a percent, multiplied by 100%, gives us 36%. Next, we have a frequency of 14. 14 divided by the total frequency of 50 is equal to 0.28. As a percentage, it is 28%. Next, we have the frequency of 5. 5 divided by 50 gives us 0.10. Multiplied by 100% gives us 10%. Next, we have, again, 5 is the frequency. 5 divided by 50 is 0.10. As a percentage, it is 10%. Next, we have the frequency of 1. 1 divided by 50 is 0.02 times 100% gives us 2%. And then the last frequency is 1. Again, the same as before. 1 divided by 50 is 0.02, which is 2%. Now we know that the total frequency was 50, but now let's add up all these percentages and see what we get. So if we add up 12% plus 36% all the way to 2%, we should get close to 100%. I mean, if we're not exact at 100%, it could be 0.99, or 99, or just slightly over it. So again, the sum of the percentages in a relative frequency distribution must be very close to 100% with a little wiggle room for rounding errors. Comparisons. When combining two or more relative frequency distributions in one table makes comparisons of data much easier. Example 3. Comparing daily commute time in New York, and Boise, Idaho. Now, the table here shows the relative frequency distributions for 1,000 commute times in New York and Boise from data set 31. Now again, here in the first column, you're going to see the classes of the daily commute times going from 0 to 14 all the way to 135 to 149. Now here are the relative frequencies. Now if you notice here, because of the different sizes of the two cities, we might expect the commute times to be very different. But by comparing the relative frequencies, we see that there are major differences. Now, the Boise commute times appear to be lower than the New York commute times, see that for Boise, the lowest two classes have 75.8% of all commute times, compared to only 28.9% for New York. This is not surprising given that the relative size and population density of the cities. So remember, the lowest two classes have 75.8% of Boise. So what they've done is they've added these together to get 75.8%. And then they compared it to the two lower classes for New York, and when they added those together, they get 28.9%.